Welcome to part 5, Error Analysis. This is without a doubt the most heavily tested section of chapter 1. Let's lock down these NCERT rules. First, let's classify errors. Systematic errors always push in one direction, either entirely positive or entirely negative. Random errors, however, are completely unpredictable. If an experiment has random fluctuations in temperature or voltage, that is strictly a random error. And here is a massive NTA assertion reason trap, least count error. The NCERT strictly classifies least count error as belonging to both systematic and random errors. Do not let them trick you on that. Now let's talk math. When you take multiple measurements, the arithmetic mean is considered the true value. The absolute error is the difference between an individual measurement and that mean. If you take the average of all those absolute errors, you get the mean absolute error. Divide that by the true value and you have your relative error. Multiply by 100 and boom, percentage error. But what happens when we combine measurements into a formula? This is called the propagation of errors, and there are absolute mathematical laws you must follow. Rule number 1, for addition and subtraction, absolute errors are additive. Here is trap number 1. If the formula is z equals a minus b, rushed students will subtract the errors. Never do this. Errors never cancel out. The maximum absolute error is always delta a plus delta b. Rule number 2, for multiplication and division, relative errors are additive. Rule number 3, the power rule. When a quantity is raised to a power, that power becomes a direct multiplier for the relative error. Which brings us to the ultimate NTA trap, the negative power denominator trick. Imagine a formula where c is in the denominator. Mathematically, that is c to the negative 1. Students often subtract the error of c because of that minus sign. Listen carefully.
All power coefficients act as strictly positive multipliers. We are calculating the maximum permissible error, so denominator terms must always be added. Let's put this to the test with some core PYQs.
Let's tackle question number 1 on error analysis. The lengths of two cylindrical rods are given as 5.62 plus or minus 0.01 centimeters and 4.34 plus or minus 0.02 centimeters. What is the maximum percentage error in the difference of their lengths? Let's look at the physical setup. We have two rods and we need the difference in their lengths. Step 1. Find the true mean difference. 5.62 minus 4.34 gives us exactly 1.28 centimeters. Step 2 is the ultimate NTA trap. Because we subtracted the physical values, rushed students assume they should subtract the absolute errors too, which would give 0.01. This is wrong. Errors represent physical uncertainty. They are cumulative and never cancel out. According to NCERT, even in subtraction, absolute errors are always added. So 0.01 plus 0.02 gives us a maximum absolute error of 0.03 centimeters. Finally, step 3, the percentage error. We divide the absolute error 0.03 by the true value 1.28 and multiply by 100. This gives us approximately 2.34%. Option 2 is the correct answer.
Moving to question number 2. A uniform thin metallic wire has a mass of 0.3 grams, a radius of 0.5 millimeters and a length of 6 centimeters. What is the maximum percentage error in the measurement of its density? Let's look at the physical setup of our wire. We have length, radius and mass. Step 1. The density formula is mass divided by volume. For a cylindrical wire, volume is pi r square L. Step 2. We convert this to the error propagation equation. The percentage error in density equals the percentage error in mass plus 2 times the percentage error in radius plus the percentage error in length. Notice how the power of 2 comes down as a direct multiplier. Before we calculate, here is a massive NTA trap. You see grams, millimeters and centimeters. Do not waste exam time converting units. Because relative error is a dimensional ratio, as long as the absolute error and the true value are in identical units, they cancel out completely. Now let's calculate the individual errors. Mass is 0.003 divided by 0.3, which is exactly 1%. The radius is 1%. The length is 1%. Plug these in. 1% plus 2 times 1% plus 1% gives us a maximum percentage error of exactly 4%. If you rushed and forgot the power of 2, you would get 3% and fall right into option 3's trap. But we know better. Option 2 is our correct answer.
Let's look at question number 3. This is a classic general power combination PYQ. We are given the formula P equals A cubed times B squared divided by C times the square root of D. We are given the percentage errors for all four variables. What is the maximum percentage error in P? Look at the error pool flowchart on the left. Notice how A, B, C and D all flow into the total error pool. Step 1. We expand the formula using the power rule. The exponent comes down as a multiplier. So 3 times the error of A plus 2 times the error of B. Now for the ultimate trap. What happens to the denominator terms C and D? Mathematically, C is to the power of -1 and D is to the power of -1/2. But remember, we are calculating the maximum permissible error. You must take the absolute value of those exponents. This means the errors for C and D must strictly be added. Never subtract errors. Step 2. Let's substitute the values. 3 times 1% plus 2 times 3% plus 1 times 2% plus half of 4%. 3 plus 6 plus 2 plus 2 gives us a total maximum percentage error of exactly 13%. If you had subtracted the bottom terms, you would have gotten 5%, which isn't even an option here, but NTA frequently makes it 1. We lock in option 1 as our correct answer.
Question number 4 is a brilliant multi-concept question. We are calculating the density of a solid ball, but first we have to extract our measurements from a screw gauge. Let's look at our instrument data on the left. The least count is pitch over divisions, giving us 0.01 millimeters. The true diameter is the main scale reading, 3.5, plus the circular scale reading times the least count, which gives us 3.8 millimeters. Step 1, we set up our error formula. Density is mass over volume, which is proportional to mass over diameter cubed. Therefore, the percentage error in density is the percentage error of mass plus 3 times the percentage error of the diameter. Here are 2 massive NTA traps you must avoid. Trap number 1, they didn't explicitly give you the absolute error of the diameter. You must remember that the absolute uncertainty of a single reading is exactly equal to its least count. So delta D is 0.01. Trap number 2, students try to divide the percentage error of the diameter by 2 because radius is diameter over 2. But relative error is a ratio. The percentage error of a radius is mathematically identical to the percentage error of its diameter. Just stick to the diameter. Step 2, calculate the percentage error for the diameter. 0.01 divided by 3.8 times 100 gives us approximately 0.263%. Step 3, add it all up. 5% for the mass plus 3 times 0.263 for the volume. This yields 5.789%. Option 2 is exactly 5.78%, making it our correct answer.
Let's close out chapter 1 with question number 5. The displacement of a moving body is measured as 200 plus or minus 5 meters and the time taken is 20 plus or minus 0.2 seconds. What is the percentage error in its velocity? As you can see in our illustration on the left, velocity is simply displacement over time. Step 1, we write out our error formula. Velocity equals s divided by t. This means the percentage error of velocity equals the percentage error of displacement plus the percentage error of time. And right there is the final NTA trap of this chapter. Because the physical formula uses division, students mistakenly assume they should subtract the relative errors. Never do this. Relative errors must always be added to find the maximum possible uncertainty. Step 2, let's calculate the individual percentage errors. For displacement, it is 5 over 200 times 100, which gives 2.5%. For time, it is 0.2 over 20 times 100, which gives exactly 1%. Finally, add them up. 2.5% plus 1% equals a maximum percentage error of 3.5%. Option 2 is our correct answer. And with that, you have officially mastered the highest yield PYQ concepts of Chapter 1, Units and Measurements. Review these traps, trust the NCERT rules, and I will see you in the next chapter. Visit neetapp.app to solve more chapter-wise MCQs and PYQs.